Let's take a look at another example here. I want to find the area between two intersecting curves. Now, in order to calculate the area between two curves that have one or more points of intersection, we must first determine the intervals where one curve is greater than the other. So we need to find these points of intersection, then figure out who's bigger than who. So in order to do that, I'm going to take these two functions, set them equal to each other, and solve. So I'm going to have sine of x equals cosine of 2x. Cosine of 2x, I'm going to use an identity for that. This implies that sine of x equals, the identity I'm going to use is 1 minus 2 sine squared of x. That would imply that 2 sine squared of x plus sine x minus 1 equals 0. Now notice that this is quadratic in sine x. So I'm going to say let sine x equal, how about t? I use t as my variable. And then that gives me 2t squared plus t minus 1 equals 0. So I don't see quick and easy solutions to this one, so I'm going to just use a quadratic formula again. I'm going to say t is equal to negative b, which is negative 1, plus or minus the square root of b squared, 1 squared, minus 4 times a, which is 2, times c, which is negative 1, over twice a, which is 2 times 2. Well, that's negative 1, plus or minus, that's root 9 over 4. So that's negative 1 plus or minus 3 over 4. That means that t is equal to, see, negative 1 minus 3 is negative 4. Negative 4 over 4 is negative 1. Or t is equal to negative 1 plus 3 is 2 over 4 is a half. But remember, t is actually sine. So that means I need to figure out where sine of x is equal to negative 1 or 1/2 on this interval. Well, that's easy because sine of negative pi over 2 is negative 1. So that means that x is equal to negative pi over 2. And then I need sine to be positive 1/2 on the interval from negative pi over 2 to pi over 2. And that's clearly going to be at pi over 6. So I know that this is going to be negative pi over 2, and this value of x is pi over 6. Okay, so with that, I can go ahead and do this integral. So I'm going to take the integral from negative pi over 2 to pi over 6. And which one's bigger? Well, if I take a look at this at 0, cosine of 2 times 0 is cosine of 0. That's 1. That means I'm right here. Sine of 0 is 0, so cosine is definitely bigger. So I'm going to take cosine of 2x minus sine of x dx. That will give me this area right here. And then I'm going to add it to the integral. So this is, this is pi over 6. So this is going to be from pi over 6 to the end here, which is pi over 2. And this time they switch places, so I'm going to have sine of x minus cosine 2x dx. And this second piece will give me the area right there. Okay, so let's go look for antiderivatives. See, cosine of 2x, antiderivative is going to be sine of 2x over 2. If you're not sure, take the derivative and you'll see that you get cosine of 2x back. And then this is going to be plus cosine of x, because the derivative of cosine is negative sine. And I need to evaluate this from a negative pi over 2 to pi over 6. So I'm going to call this piece 1, and let's just work on piece 1 for a minute here. Let me separate these a little bit. So at pi over 6, and I put pi over 6 for x, the 2 cancels the 6 and I get pi over 3. Sine of pi over 3 is root 3 over 2. It's divided by a half plus cosine of pi over 6 is root 3 over 2. Minus, now I need to evaluate both of these at negative pi over 2. Well, the 2's that cancel, I have negative pi. Sine of negative pi is 0. And at cosine of negative pi over 2, cosine is also 0. So this is just 0. So this is going to be, what am I going to have here? I'm going to have root 3 over 4 plus root 3 over 2, which is going to be equal to 3 root 3 over 4. So that's going to represent that first piece. Now I need to work on this. This is going to be, the antiderivative of sine would be a negative cosine of x. And then I'm going to have minus sine of 2x over 2. And I need to evaluate this from pi over 6 to pi over 2. Well, at pi over 2, this negative cosine is going to be 0. So I'm going to have, I'm just going to factor this out, this negative out. Whoops. I'm just going to factor that negative out of there and make it all positive to work with, and then take the negative of the whole thing when I'm done. So this could be 0. Pi over 2, 2 cancels pi, that's 0 plus 0. Minus, at pi over 6, cosine of pi over 6 is going to be root 3 over 2. And sine of 2 times pi over 6, that's sine of pi over 3. That's going to be root 3 over 2 over 2, just like we had over here. So I'm going to end up with this double negative, which is a positive. So this is also going to give me 3 root 3 over 4. So if I take these two and combine them together, I will get 6 root 3 over 4, which is, of course, 3 root 3 over 2. So my area under the curve, or between these two curves, the net area, and I really want to emphasize the net area for a moment there, is 3 root 3 over 2. And the reason I say net is because all this down here is going to be negative. This is going to be a negative contribution. Up here is going to be a positive contribution, and up here is going to be a positive contribution. So the total, the net area, is a positive value. It's positive root 3 over 2.